In practical terms, pulleys allow heavy objects to be lifted using a much reduced force. If you lift something up slowly and smoothly over a certain displacement, the force you apply is equal to the weight of the object, which is determined by its mass and the force of gravity pulling it downward. However, if you lift something using a longer path, like a ramp, instead of straight up, you don't have to use as much force. The longer path makes it easier to lift the object to the same height, then the applied force will be less than mg. Before examining how pulleys create this mechanical advantage, let's consider first the heavy block in the figure above, suspended from two ropes. Because the block is not accelerating, it is in transitional equilibrium, and the force that the block exerts downward is cancelled by the sum of the tensions in the two ropes. For a symmetrical system, the tensions in the two ropes are the same and are each equal to half the weight of the block. Now let's imagine the heavy block in the figure above. This represents a heavy crate that must be lifted. Assuming that the crate is momentarily being held stationary in midair, we again have a system in transitional equilibrium, which means that the load is balanced by the total tension in the ropes. The tensions in the two vertical ropes are equal to each other. If they were unequal, the pulleys would turn until the tensions were equal on both sides. Therefore, each rope supports one half of the crate's total weight. By extension, only half the force is required to lift the crate. This decrease in effort is the mechanical advantage. The idealized pulley is mass-less and friction-less, and under these theoretical conditions, the work put into the system, which is the exertion of force through a distance of rope, will exactly equal the work that comes out of the system. Real pulleys, and all the real machines, fail to conform to these idealized conditions and do not achieve 100% efficiency in conserving energy output to input. Efficiency is often expressed as a percentage by multiplying the efficiency ratio by 100%. The efficiency of a machine gives a measure of the amount of useful work generated by the machine for a given amount of work put into the system. A corollary of this definition is that the percentage of the work put into the system that becomes unusable is due to non-conservative or external forces. The pulley system in the figure above illustrates the fact that adding more pulleys further increases mechanical advantage, means for each additional pair of pulleys, we can reduce the effort. In this case, the load has been divided among 6 lengths of rope, so the effort required is now only 1/6 the total load. Remember that we would need to pull through a length of rope that is 6 times the desired displacement, and that efficiency will decrease due to the added weight of each pulley and the additional friction forces. Don't forget to like and subscribe.